All right, everybody. Today we are looking at section 3-4, writing and solving multi-step equations. Today, big difference here. You are going to have to write the equations and then solve it. So instead of being given the equation, you're going to have to take this real-world example, write the equation, and then solve it. That's pretty much what this learning intention says right here. I am learning to write and solve multi-step equations that represent real-world situations. Success criteria for the day. I can write an equation to match a specific situation. And then similar ones to what we've had the last couple days. I can use the distributive property and combine like terms, and I can solve multi-step equations with variables. Hopefully right now you're able to check off these two, that you feel comfortable with multi-step equations and distributive property and combining like terms. Really the only new thing we have today is writing the equation based on the situation given. So if we look at example 1 here, we have our 2 steps. You got to write the equation, then you have to solve it. So Miss Hill is designing a rectangular vegetable garden for her backyard. The width of the garden is 11.5 feet shorter than twice its length. So we're going to have to break all those words down, figure out what equation we're going to write. So in the bold there, bold means important. Bold means important. That's where our question is actually going to come from, because the beginning of that doesn't really tell us anything. So if the perimeter of the garden is 37 feet, what is the length of the garden? So that's, we know right now, our final answer should be the length of the garden. Write and solve the equation, check your solution. So we're dealing with perimeter of a garden, rectangular vegetable garden. So I'm going to draw up here a little garden. I don't know if it's to scale. I don't know if that's the right way to draw it. We're just putting something out there for it. Okay? We have the length, because if it's a rectangle, we have length and we have width. What information did they give us for each of these? The width of the garden is 11.5 feet shorter than twice its length. So as we're going through this, they told us a lot about the width, 11.5 feet shorter than twice its length. Well, that tells me right now, I know a lot about the width, so the width is going to be the longer one, the one that has more numbers in it. They didn't really tell me anything about the length. So the length of this, that's going to be where our variable comes in. We're dealing with we're dealing with variables. Variables are going to be in this. Because they didn't tell me anything about the length, I know that has to be my thing that's just a variable. They didn't tell me anything else about this. But they told me the width of the garden is 11.5 feet shorter than twice its length. So if I said the length was twice the width, and the length is x, what can we do to the x to say that it's twice that? In other words, let's say we're talking you and me. I said I had twice as much money as you. How would you figure that out? I have $10. You have $10. I have twice as much money as you. That means I would have $20 because I have twice as much. I multiply by 2. So whenever it says something like twice its length, I'm able to take that x that we said, because they didn't give us any information, and just say 2x. The width is, and we're going to get to this other part first, but that twice Just means we multiplied by 2. Then we have 11.5 feet shorter. If I'm 6 foot tall and you're 2 feet shorter than me, how are you going to figure that out? Are you going to add, subtract, multiply, or divide? Because it says shorter, we're going to subtract. So 2x minus 11.5. All right. Okay, as you start doing these more, as we continue to work on these, you'll get better at understanding where these things are coming from. But again, they gave us a lot of information for the width, didn't tell us anything for the length. So that tells us that the length was just x, and then we had to go through the 11.5 feet shorter than twice. That's where we get this from. Now, how do you find the perimeter? You got to add up all the sides. You've got length, width, length, width. We got to add all those up. So let's go around. We said the length was just x, so we're going to put that there. Then we got the width. So plus, perimeter is adding all the sides, 2x minus 11.5 plus another length, so plus x, plus another width, plus 2x minus 11.5. We're solving an equation, so it's got to be equal to something. What's it equal to? Well, that was here in the bold. Bold means important. It's 37 feet. So it's all equal to 37. Now we have to solve. All right. We're going to go back to what we did in lesson 3.2 or 3-2 because we have variables on one side, no variables on the other. So it's not what we did last section. We don't have to go back and forth. We just have variables on one side. So what I would recommend doing is putting a box around anything that has a variable with any addition or subtraction that's in front of it. Okay. Put a box around those. Underline anything that's just a number. We're only working on one side. I don't care about 37. It's all by itself. I just care about the side that has a whole bunch of stuff on it. We're going to move the similar things next to each other. So everything that's in a box, let's put it next to each other. X plus 2x plus 2x. I've used this, I've used this, I've used this. Now let's bring in the things that are underlined and put it next to each other. Minus 11.5 minus 11.5. That's all still equal to 37. Combine like terms. X, remember, it has that little imaginary 1. So 1x plus 2x plus 2x gives us what? 5x. Minus 11.5 minus 11.5. Again, if you need to use your calculator, use your calculator. We're going to get minus 23 equals 37. So we combine like terms. And now we have a nice two-step equation here. We know how to do this. Draw your line, circle your variable and everything that's attached to it. We can't touch this yet until we get rid of everything else on this side. We have this minus 23. How do we get rid of a minus 23? We have to do the inverse, or the opposite, and the opposite of subtraction is addition. So plus 23, that cancels. We're left with 5x equals 7 plus 3, 0. Carry your 1, 60. What's my final step here to get the x by itself? It's attached, so we have to divide. Divide. 5 divided by 5 is 1, so that cancels. We are left with x is equal to 60 divided by 5, 12. X is 12. All right. And if you have any questions, let's go back. Let's see if we plug it in, if we get the right answers. Who knows? Maybe we did something wrong. Who knows? Okay. I think I see something wrong. Mr. Short was going too fast. There was another X there. I made a mistake. How can we fix this? I know I need to add another X. So let's put another 1X there. What does that change? This becomes 6X. This becomes 6X. I divide by 6. That means my answer is 60 divided by 6 is 10. That's why it's so important to check your work. I did it real quickly in my head, but now I'm going to go plug it in. All right? The length was just x. So 10 plus 2 times 10 is what? I'm going back to my original equation. 2 times 10 is 20. Minus 11 and a half. Plus 10. Plus 2 times 10, 20. Minus 11 and a half should equal 37. So I'm just going to combine everything I can. All right. I don't want to deal with the negatives yet. I just want to deal with all the positives. 10 plus 20 plus 10 plus 20. So 30 plus 30, that gives me 60. Minus, we did 11 and a half minus 11 and a half over here. That was 23. So I've used everything in here now. 60 minus 23 is 37 equals 37. Because we get the right answer, we know our x equals 10 is correct. If we'd have plugged 12 into that, we'd have gotten the wrong answer. I make mistakes too. That's okay. Okay? We have to learn from our mistakes. I went too fast. I wasn't paying attention to what was right here. I missed that x. Why? I don't know. It happens. All right? Let's move on. Let's try another one. Mr. Murphy's class of 20 students is going on a field trip to the Science Center. That doesn't make sense. Mr. Murphy is a social studies teacher. They will also watch the 3D movie. Ms. Todd's class of 15 students is going on a field trip to the Art Museum and will take the audio tour. Admission to the Art Museum is 2.5 times that of the Science Center's entry fee as shown in the table. So right there it's telling us all the information we need to know is in the table. We have some bold there, and bold means important. This would be a good time if I know in your ELA classes you are doing text writing and annotating and highlighting and underlining and things like that. Please use those skills here when you see a word problem like this. Figure out what's important. All right. So if the total cost is the same at both the Science Center and Art Museum, what is the entry fee per student to the Science Center? Again, check your solution. So, if the total cost is the same at both the Science Center and Art Museum, what is the entry fee per student to the Science Center? All right, well, let's figure this out. Did they tell us how much it cost, or did they just tell us that it was equal? They told us it was equal. So unlike the one up top where they told us what the perimeter was, we don't know what the total cost was, They want to know what is the entry fee per student. So we are solving for these two things right here, and notice how they both have an x. What that tells me is that when we set this up, we're going to have, I'm going to do it over here so that I have plenty of room to work through here. I'm going to have science equals art. I'm going to write an expression for the Science Center and set it equal to the total for the Art Museum. Both of these say per student. We talked before that if you see that per, we're going to multiply something. What are we going to multiply? Well, how many students went? How many students went to the Science Center? Well, let's see. Science Center is right here. Mr. Murphy's class went to the Science Center. There were 20 students. So I have 20 students that each had to pay the entry fee and the movie. So if one person had to pay this, they'd pay the entry fee and the $2.50. If two people paid, they'd pay twice the amount here, twice the amount there. If 10 people went, it'd be 10 times this and 10 times this. What do we know where we're going to multiply multiple things by the same number? That's the distributive property that we've been working on. Remember, I can use the distributive property. That's been on our sheet for the last, 2 weeks, something like that. We're going to multiply, that's why I'm putting parentheses, this expression. Because let's say it was $5. You're paying the $5 entry fee plus the $2.50 for the 3D movie. So I'm going to say x plus $2.50. This is each student, is whatever the entry fee is plus $2.50. But there's 20 of them, so we're going to do 20 times that. Let's do the same thing for the art museum. How many students went to the art museum? All right, it's an art museum right here. Miss Todd's class of 15 students. So I'm going to start out that same way. 15 times the cost of the ticket, so 2.5x, plus that 1 for the audio tour. All right? So, now we have to solve this equation. 20 times x plus 250 is equal to 15 times 2.5x plus 1. Well, let's go through our distributive property. 20 times x, 20 times 2.5. Remember, there's an invisible 1 there. That gives us 20 times x, 20 times 1, 20x, plus 20 times $2.50. Or 20 times 2.5 if you're plugging it in your calculator. That's going to give us 50 equals 15 times 2.5, 15 times 1. So when you plug that in, 15 times 2.5, remember we're going to have the x attached to it. So that's going to give us 37.5 x plus 15 times 1, 15. Now we have to solve this equation. We have variables on each side. We've already distributed. Can we combine anything on the left-hand side? We have 20x and 50. Can we combine something that has an x with something that doesn't? Nope. How about on the right-hand side? We have 37.5x plus 15. Can we combine stuff that has an x with something that doesn't? We just said no. So, I always want to move the smaller x. So what's bigger, 37.5 or 20? 37.5 is bigger, so I want to move this 20x. 20 is positive, so how are we going to get rid of positive 20x? Well, we're going to subtract 20x, 20x. The way that cancels. We're moving our variable to the right, so we got to get rid of that number on the right. How are we going to get rid of plus 15? We're going to subtract 15. Subtract 15. So what are we left with? 50 minus 15 gives us 35. 37.5 minus 20, that gives me 17.5x. All right. So I'm going to move this over here. 35 is equal to 17.5x. We have 17.5 attached to the x. That's all we have left. How do we get rid of something that is attached? What's the opposite? We divide by 17.5. That way it cancels. What you do to one side, you do to the other. So what do we get when we divide 35 by 17.5? We get 2. X equals 2. But did they ask for x or did they ask for something else? Well, let's find out. Okay. So let's go back to our important and what we underline. What is the entry fee per student at the Science Center? So Science Center entry fee, all it was x. We found x. X was 2. We're done. That's our answer. The entry fee is $2. If, they didn't ask this, but if instead of Science Center, they had said Art Museum, we would have had to plug this X into our admission to the Art Museum. We would have had to say 2.5 times X, which was 2. 2.5 times 2 gives us 5. So this is for the Science Center. This is for the Art Museum. Did they ask us for that? No. But I can almost guarantee on some test that you're going to see somewhere down the road, you're going to be asked the same exact question or a question like it, and instead of just having to solve for x, you're going to have to plug it back into something else. I can say with about 100% certainty that that's going to happen at some point. So make sure you're going through understanding what you need to solve for. This is something different than what you've had to do in the past. You haven't had to create your own equation. That's what we're asking you to do here. These are the only 2 examples that I have for you right now. I want you to take a look at page 109 and see if you can't figure out those equations given those real-world situations. You have 3 of them on that page. Okay. I want you to try to write that equation, and annotate, text mark, highlight, underline, whatever you need to do so that you know what the important information is, and see if you can't write that problem. All right. Again, if you have questions, please send me a message through Google Classroom. Ask Miss Ellis or Miss Smith, whoever's in class today. Let me know what questions you have. All right. Good luck, you guys.